All right, in order to simplify this radical expression, we need to follow these two rules right here. There are a couple of other rules for radicals, but these two are all we need for this problem right here. Number one is this idea that when you take the square root of an expression that has an exponent, you divide that exponent by 2. You might not have seen it like that before, but here's just a quick example. When somebody gives you the square root of 16, maybe out the gates you know that's 4, but the reasoning for that in this kind of case is that 16 is the same thing as 4 squared. Then when we take the square root, and again you wouldn't have to go through this whole step, but what that you would get is 2 divided by 2. That's this step right here, where you're dividing the exponent by 2 to get to 4. Now again, hopefully if you understand the basics of square roots, you can get from here to here. The square root of 16 is 4 because 16 is 4 squared. All right, the second one is rule number 2. Rule number 2 is the product rule of radicals, and it allows us to split up a radical using multiplication. Here's just a quick example. This is very different than we're actually going to use it, but if I had something like this that was the square root of 2xy, that rule just says however we'd like, we can separate this over multiplication. So that could be equal to, for example, 2x times the square root of y. Another way of doing that, if we could split that up however we'd want to, so just for an example, we could have split that up to be a square root of 2 times the square root of xy, however we'd like to. So to take the square root, we divide exponents by 2. Number 2, we split up radicals based on multiplication. All right, so to jump to this problem that we're working on over here, a couple things. First, I'm going to break up anything that needs to be broken up. And I can go in more detail, but simply put, I'm going to split up the stuff that works well with the square root from the stuff that doesn't. And you get better at this, but for instance, 48 I know is 16 times 3, so I'm going to write that as 16 times 3. And again, I'm doing that because the 16 here works well with the square root, just as I described on the side over here. And then as we times this x to the 4th, I'm keeping that the same. The reasoning, as you'll see in the next example, since I want to divide exponents by 2, I need exponents that are even to work nicely. So what I'm going to do with this y to the 5th is I'm going to split it into y to the 4th times y to the 1, or just y right here. All right, now what I'm going to do is I'm going to apply the second property here and split this up over multiplication. Multiplication is the only operation going on, so I can split this up however I want. The stuff that I've underlined here in blue is the stuff that's going to work well with the square root. So I'm going to put that in the first square root, and in the other square root I'm going to put this 3 and then the y by itself. So what I'm going to get are two different square roots. This first square root is 16 x to the 4th y to the 4th. The second square root is what I call the remainder type stuff, which is 3y. Okay, and again, remember the stuff in the first square root is all the stuff that I determined works well with the square root. The second set of stuff is the stuff that doesn't work well. And actually, the first square root is going to change dramatically on the next step, and the second one is going to stay exactly the same. What I do now is I'm going to take the square root of all the stuff in that first radical, or the first square root. I can do that individually. The square root of 16 is 4. The square root of x to the 4th is x squared, because again, as rule number 1 states, I take the square root by dividing the exponent by 2, and then the y to the 4th becomes a y squared. So I took the square root of all of those things, that's why there's no longer a square root around it, and then I leave this second radical square root exactly the same. This is my final simplified form. All of the stuff that I could take the square root of is now on the outside, and it has been square rooted. Whatever couldn't, or the leftovers, is left inside of the radical.